Wait. Don't scroll. You think you know Mars? That red, silent planet that looks cold, lifeless, frozen in time? But let me ask you this. Is Mars truly silent? Or have we simply not learned how to listen yet? If the planet is dead, why does it still shake? Those vibrations we're recording, where are they really coming from? And here's another question. If water vanished from the surface long ago, did it disappear forever? Or is it still there, hidden beneath ice and stone, waiting in the dark? Think about this. If life can survive deep beneath Earth's surface, could Mars be hiding similar environments below its own crust? This isn't speculation. This isn't science fiction. This is data. These are signals. This is Mars speaking to us through science. Today, we're going beneath the red dust. We're entering the planet itself, a place where rocks become records and silence begins to ask questions. Stay until the end and tell me in the comments. Backhand index pointing right, do you believe Mars is truly dead? Or is its real story still buried underground? And if you're fascinated by the hidden side of Mars, like this video, subscribe to All About Mars Surface and share it with someone who loves space mysteries. Your support helps us keep uncovering the secrets, written not on the surface, but deep beneath it. This is All About Mars Surface, and this story is only just beginning. A distant world, a silent surface, and a history hidden far below. The red planet holds a story, one that does not begin on the surface, but deep beneath it. Welcome to All About Mars Surface, where we travel past the rust-colored dust, beyond endless plains, and into the unseen depths shaped by cold, pressure, and time itself. This episode uncovers the hidden interior of Mars, an underground realm built from stone, ice, heat, and billions of years of planetary evolution. Long before the first spacecraft ever approached its orbit, Mars was already forming its identity layer by layer beneath its surface. What appears today as a quiet, frozen desert still carries the memory of powerful forces that once worked tirelessly within its core. Mars was born over 4 billion years ago from the same swirling cloud of gas and dust that formed Earth. In its earliest era, the planet was far from calm. It was hot, unstable, and geologically alive. Vast volcanoes erupted repeatedly, releasing oceans of molten lava across the surface. Beneath the crust, massive chambers of magma formed and shifted as internal heat pushed upward. As the planet slowly cooled, its crust thickened, locking much of this activity beneath the surface. These early processes shaped everything that exists on Mars today. Towering volcanoes, deep valleys, and immense underground structures all trace their origins to this violent beginning. Beneath the familiar red soil lies a thick crust composed largely of basalt, forged by ancient volcanic flows. Below that rests the mantle, a dense, mineral-rich layer that once transported heat from deep within the planet toward the surface. At the center lies a metallic core rich in iron, sulfur, and nickel. Although Mars is smaller than Earth, its interior tells an equally complex story. Pressure, chemistry, and slow energy movement have shaped the planet over immense spans of time. For decades, scientists believed this story had ended, that Mars was completely geologically dead. Its surface appeared unchanged, frozen in a distant past with no active plate tectonics or internal motion. That assumption began to change with modern exploration. Sensitive instruments carried by orbiters and landers detected subtle vibrations within the Martian crust. These faint tremors revealed that Mars is still adjusting internally. The planet may be quiet, but it is not entirely still. One of the most groundbreaking discoveries came from NASA's InSight lander. By recording Mars quakes, scientists were able to track how seismic waves traveled through the planet's interior. This data allowed them to calculate the thickness of the crust, analyze the mantle's composition, and estimate the size and state of the core. The results were surprising. Mars has a large, partially liquid core and a mantle that still retains heat from its ancient, turbulent past. Internal heat has played a defining role in shaping Mars's underground environment. In its early history, this heat fueled enormous volcanic systems. Some Martian volcanoes grew larger than anything found on Earth, becoming so massive they altered the planet's gravitational field. Beneath these giants, magma chambers formed, expanded, and collapsed, leaving behind vast hollow regions within the crust. These empty spaces became conduits for fluids, gases, and minerals. When water was abundant on the surface, it seeped downward through fractures and faults. Over time, it accumulated in underground layers, forming reservoirs trapped beneath rock and ice. Even after rivers and lakes vanished from the surface, water may have survived below, shielded from radiation and extreme temperature swings. Orbiting radar instruments later detected unusual reflective signals beneath Mars's polar ice caps. These signals suggest the presence of liquid or semi-liquid water mixed with salts, dense underground lakes buried beneath kilometers of frozen ice. If confirmed, these reservoirs would represent some of the most stable environments on the planet. Conditions underground remain far more constant than on the surface. Temperatures fluctuate less, radiation is weakened by thick layers of rock and ice, and slow chemical reactions continue in darkness. Water interacting with minerals reshapes the Mars surface, dissolving elements and forming new compounds over millions of years. Perseverance on Sol 3991 Mars's rocks preserve this chemical history. Clay minerals, sulfates, and carbonates, materials that form only in the presence of water, have been detected across the planet. These minerals act as records, showing that water once moved through the crust, altering the rock it touched. As water flows, minerals dissolve, crystals form, and microscopic channels develop, gradually transforming entire underground regions. Some zones become hardened and sealed, while others weaken and hollow out. Even today, small amounts of salty liquid water could persist deep underground, flowing slowly through tiny fractures. In these protected environments, organic molecules could survive far longer than they can on the surface. Carbon-based compounds have already been detected in Martian rocks, and underground, they would be shielded from the ultraviolet radiation that rapidly breaks down complex chemistry above ground. The underground world of Mars is not an empty void. It is layered, structured, and continuously shaped by invisible forces. Pressure increases with depth, transforming minerals into new forms. Heat rises slowly, altering the physical properties of rock. Chemical reactions proceed silently, creating materials never exposed to the surface. Some regions of the crust are strongly magnetized, preserving evidence of an ancient magnetic field. This field once protected Mars from solar winds. When it weakened and disappeared, the atmosphere began to erode, and surface water slowly vanished, either escaping into space or retreating underground. Deep beneath the plains, ancient river systems may still exist as buried channels filled with sediment. These fossilized pathways mark where water once carved through rock, transporting material across the planet. Over time, volcanic ash and dust sealed them away, preserving evidence of an underground water cycle similar to Earth's aquifers. Today's rovers cannot drill deep enough to reach these hidden layers, but their discoveries guide future exploration. Sample return missions aim to bring Martian material back to Earth for detailed analysis. Some samples may contain microscopic structures formed underground, locked inside minerals for billions of years. Even without signs of life, they reveal the conditions that once existed within Mars' surface. Future missions may carry advanced drilling systems capable of reaching deeper into the crust. These tools could extract ice, minerals, and possibly liquid brines, helping scientists understand how Mars stores water and how its interior continues to evolve. Understanding the subsurface is also critical for human exploration. Future explorers will depend on underground water for drinking, oxygen production, and fuel. Subsurface ice and reservoirs could become essential resources for long-term missions. Underground habitats could provide protection from radiation, extreme temperatures, and dust storms. Natural caves formed by ancient lava flows, known as lava tubes, have already been identified from orbit. Some stretch for kilometers beneath the surface and are wide enough to shelter entire habitats. Inside, temperatures remain relatively stable, radiation levels are lower, and thick rock walls provide insulation. These caves could become humanity's first safe shelters on another planet. Beyond survival and science, The underground world of Mars is the planet's deepest archive. Each layer preserves a chapter of its past, written not in words, but in stone. Volcanic eruptions, floods, climate shifts, and atmospheric loss are all recorded beneath the surface. Mars may appear silent today, but beneath that stillness lies a world shaped by ancient fire and water. The planet continues to cool slowly, releasing heat at a pace too subtle to see. Every detected tremor is a reminder that Mars is still evolving, still settling into its final form. The deeper we look, the clearer Mars becomes, not as a lifeless rock, but as a complex planetary system shaped by the same forces that shaped Earth. Its surface may be quiet, but its underground world speaks through data, minerals, and faint vibrations. The southern hemisphere is older, higher, and heavily cratered. The northern hemisphere is younger, smoother, and lower in elevation. This difference suggests that Mars experienced major geological changes early in its history. Large impacts, internal heating, and volcanic resurfacing likely reshaped vast areas of the planet. Impact craters dominate much of Mars. These craters formed when asteroids and comets struck the surface, especially during the early solar system when impacts were more frequent. Some craters are shallow and eroded, while others remain sharp and well-preserved. Their condition helps scientists estimate their age. Older craters appear worn down by wind and dust, while younger ones have crisp edges and visible ejecta patterns. Among the most studied craters is Jezero crater, a site chosen for exploration because it once held water. Inside Jezero, scientists identified an ancient river delta preserved in stone. Deltas form when flowing water slows down and deposits sediment. On Earth, these environments are excellent at preserving biological material. On Mars, the delta shows layered sediments that could only have formed in the presence of long-lasting liquid water. Rock layers are one of the most important features on Mars. Many cliffs and crater walls expose stacked layers of sediment. Over time, this radiation alters surface materials and contributes to atmospheric loss. Without magnetic protection, Mars gradually lost much of its atmosphere, leading to the cold and dry conditions present today. Despite these harsh conditions, the surface preserves ancient features remarkably well. With no plate tectonics, little rainfall, and limited erosion, Mars acts as a time capsule. Features billions of years old remain visible, allowing scientists to study early planetary history in ways not possible on Earth. Rovers like Curiosity and Perseverance examine surface rocks directly. They drill into stones, analyze their chemistry, and capture high-resolution images. It tells the story of heat that once surged, water that once flowed, and chemistry that continues in darkness. Mars's hidden depths do not promise life, but they preserve the conditions that once made life possible. From frozen plains to molten depths, Mars carries the memory of a world that was once far closer to Earth in nature than it is today. All About Mars Surface will continue to uncover these chapters, written not in ink, but in stone. Thanks for watching.